Okay, lambs, I'm taping, so we're quiet now. Jack's watching me. Thank you so much. I am on mic'd in, so it's always awkward if I have to call you by specific name. Here's what. Our goal tonight, or actually our goal tomorrow and the next day, is we're going to do problems that look like this. Don't write it, just watch me for 2 seconds. We're going to have problems that look like this. To the fifth plus 3x to the fourth plus 5x squared minus 7, 1, 2, 3, 4, x plus 3. We're going to be looking for answers. We're going to actually be graphing these crazy ones. And we're going to be looking for answers. But the problem is, don't like this. The problem with this guy is, here's what I know how to do. I know how to do two-parters. I just square root, square root. I know how to do three-parters. It's X factoring. I know how to do four-parters. I cut it in half. But the problem with this one is 1, 2, 3, 4, 5. Holy hell, I don't know how to do that. It's got too many parts to it. So we need another tool so we can make this problem a little bit smaller. We want to be able to take some out and get it smaller so we know how to deal with it. Because we know how to deal with two-parters, three-parters, and four-parters. 5, 6, 7 parters we don't know how to deal with. So we have to use some tools that we have. And we have a tool from last year. And that's my job, is to remind you of this last tool for solving polynomials. And then we're just going to start solving these bad boys. And the last tool we used last year was called polynomial long division. I love that y'all made that noise. I'm sorry that someone hurt you, because I am about to show you my favorite thing in the world, because you're right. Polynomial long division was a monster. It was one of those ones, it took a whole page and it was long. And here's really what you did. We did this in 3rd grade. I would say to you, hey, divide 157 by 6. And when you were in 3rd grade, this is what you did. You said, does 6 go into 1? No. 6 goes into 15 2 times. 2 times 6 is 12. You did a little subtracty. Yay. Goes in 6. 6 times 6 is 36. Get a little 1. And when you were in 3rd grade, your favorite thing was, sometimes you did this. You did remainder 1. You liked that. Or your teacher was mean and they made you do this. 1 over 6, right? That's literally what we did here. And your teacher showed you how to do it. And you didn't love it. And then the next day they tricked you. Because the next day when they came in, your teacher said, oh, by the way, there's a shortcut. And you were like, holy hell, why didn't you teach us that from the beginning? Am I going to go over polynomial long division? I am not. Because we want to use the shortcut. And do you guys remember the name of the shortcut for this? Synthetic division. Synthetic division. My favorite thing in the world to do. And here's what. You don't remember how to do it because no one does every year, because we don't do it enough that we remember how to do it. But once I remind you how to do it, you're going to be like, oh my God, I totally remember this, right? So synthetic division does everything division does, but it takes some really cool shortcuts. The first shortcut that it takes is this. Every time in regular division, when we do regular division, we do subtract. We do subtract. We do subtract all the way through. So in synthetic division, it says, what if instead of doing a bunch of subtracts that we don't like, what if we take care of that right from the start? And instead of using the +3, we use instead the opposite, or -3. Then we can do addition the whole way through. So that's the first thing we do with synthetic division, is that what we're going to do is take this guy, not use the +3, use what comes out. Remember the naughty stuff. So we're using the naughty stuff, and we're going to put it right there. Let's see if you guys are starting to remember what this guy looks like. I swear I don't know who hurt you. No, you will like it today. I swear it's so easy. Now, broke you. The next thing is, we don't care all those goofy X's, we can put them in at the end. Let's just worry about the things that matter to us. And you know what matters to us? The front numbers, the coefficients. So do me a favor, grab those guys down. You are going to ace this. I see, it was easy. Here's the trick though. This is the place that everyone gets killed on this. Man, it is really multiply and add, multiply and add, multiply and add. And what everyone wants to do, me included, is you kind of want to start a little action right here. So here's what I need to remind you. The first step is the key step, and it's so easy, but it's so easy to forget. The first step is to bring down the 7. The 6 and the 7. Now we have 2 steps. Multiply, add, multiply, add, multiply, add. If you can multiply and you can add, you can do synthetic division. Here we go. -3 times 7, -21. That's the multiply. Here comes the add. -3 times 15. I'm sorry, times 5 is -15. That's the multiply. Here comes the add. -3 times 5 is -15 again. That's the multiply. Here's the add. So the question is, Miss T, what the hell? That doesn't really look like anything. So what we're doing now is we're going to say we've taken out this, what's left? And here's what's left. Because I took out an x, this x to the third is dropping down a degree. So what's left over now is not 7x to the third, but 7x squared plus not 5x to the second, but 5x, and not plus 5x, but plus 5 nothing. And that -7 is our remainder. He's our leftover, and we just make him into a baby fraction. And that is synthetic division. It's that easy. Change the first guy, drop it down, multiply and add. I love things that look hard and are easy. Talk to me. You take whatever is the opposite of this. Because what we're actually doing is plugging in -3 to this equation. So we use the -3. Yes. Ella, that's you, baby. So the answer is? Yeah, so you could do it like this. Some people do this minus that fraction, or I like doing it like this, plus -7 over here. Yeah. So here's what it could look like fancy. Let me show you what it would look like fancy. Hold on. Ignore this. That's something else. So LA could look like this. 7x to the second. Got it? Oh, you have to make it like that. Yeah. Why the guys? Thanks. -2. Oh, let me see that. Oh, good question, because that is really a fraction of a thing. It's not a whole thing. It's just a fraction of one. So this is where we ended with whole number. So just like this, check this out. That's a great question. Remember when we got this, and when we were in 3rd grade, we got 1 at the end? I couldn't just put the 1 up here, right? Because it's really not a whole 1. It's a 1/6. It's the leftover. So since I've used up everything at the very end of this guy is the leftover. He's my remainder. Right? We like them best when the remainder is 0, and that's mostly what's going to happen tonight, because that's what's produced by us. Glad you asked that. So what Armani asked is this. That -7 is kind of throwing her, and she's right. That's not a very usable thing to me. Like, I'll be honest, that is not super usable to me. What's usable to me in pre-calculus is when there is no remainder, when at the end I get a 0. So let's take a look at when that happens, because that is what we want to start happening. So please do this problem right now. It looks scary. It's not. It's not. No whining. It's so easy, and like it looks so much scarier than it is. I promise you. I love things that look scary and so aren't.
I'm sorry.
Oh, so if it's negative, we turn it positive.
Exactly. Because what that does is that means we don't have to subtract the whole way
I
through.
thought we wanted it negative.
No, we wanted the opposite.
Opposite.
Yeah, because you know what? I don't like subtracting the whole way through, right? So if I deal with the opposite from the get-go, it's, in other words, instead of doing subtract, 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 I've done it right here. Does that make sense?
No remainder.
Yes, there is no remainder. Yay! Did I hear 6, 7 out there?
I thought we multiplied the 6 by negative. What? What am I doing? What am I?
Oh, it's
So here's what I do when I do these. I put a happy face if I get a 0 on there. And I'm going to tell you why. Because now this baby is clean. What we say is, yes, that goes in perfectly. It's a factor. So tomorrow, what I'm going to be able to do now is take a 5-parter, and I have, in essence, turned it into a 4-parter that I can cut in half. So let's take a look at that 4-parter. It is b to the 3rd minus 2b squared plus 2b minus 8. And tomorrow, we'll factor him. We will cut him in half, and we'll get all the answers out. So we took a scary one and made it less scary. Girls, that's our goal. Scary to not scary. It only happens when they are perfect factors. Those are the ones we love. When they have a remainder, we don't love them. When they have no remainder, super happy about that. We have another one to try, and then we have one more problem, and I'm shutting up. The next one is right here, but I need you not to write it quite yet. Take a look at this one. There's a little issue here, and the issue is this. The only way that synthetic division works is if it's written in what we call descending order. And we almost always do that naturally. 4, 3, 2, hidden 1, 0, right? We do it automatically. But take a look at this guy. There's a problem here. The problem is this. I have a 4, I have a 3, I have a 1 and a 0. Karen, what am I missing on this guy? I'm missing the squared guy. So I have to put a space for him. I put a 0 in his space, right? I have to have something for this guy right here. So I am going to put in this guy a 0a squared, right? I'm giving it, I just need I need a space holder. Otherwise, it all gets crammed together. So now try this problem, but make sure you've got your 0 in there. So the only thing I'm going to tell you is it's so tempting tonight to just start these right away. Take, like, every time a kid missed one in 0 or first, like they look back over and they're like, it was a 0. And they made that scary noise. This has a cool answer. I love the answer to this problem. It is a factor. You're going to get 0, but you get a very cool little answer. So give it a try. Well, it's not really cool.
I like it.
Wow. Wow, that was a little terrifying. Wow. 1, -4. Whoa, 0. I almost did it myself. 0, 1, -4. Watch this. I'll show ya. So the first thing is, if I ask you, is it a factor? The question is, do you have a smiley face at the end? If you got a smiley face at the end, the answer is yes, it's a factor. Half of your homework tonight is just yes or no. Do you get a smiley face at the end? If I want to know what is left, then what you do is this. Well, let's take a look at this guy. A to the third. Ooh, look, a squared goes away. A to the first goes away. Plus 1, my final answer, the very cool little answer. A to the third plus 1. That is the answer. Yes. Yeah, because it's 0. Well, we love her. We love her. Only because it's DP, I'm letting you go with this. Okay, we got one last one to do, and I'm not gonna lie to you. This was all algebra 2 and algebra 2 trig. Our next problem is pre-calc. Get ready to write this one down. This one's a little rigorous. Here we go. Rigorous.
Oh, noble.
Chernobyl. That's supposed to be the number 10. I didn't draw the weird mushroom guy.
You cover it in like white words.
I know. I was just trying to go fast.
I forgive you.
Oh, why is it taking so long? I had a kid once who had a little anxiety disorder, and if I like left a mark, he'd come up and be like, I can't. Okay, here we go. This guy is a little bit tricky. And here's what we're doing. We're using synthetic division to do a new type of problem. Cohen's watching me because this one's Cohen. This one's different. Here's what we're doing. We're going to use the fact that we know this baby at the very end will equal 0. We know that this baby goes inside of it perfectly. We're going to try to use all that information to figure out what that letter is. And how do we do it? We do it just like normal, but you guys are going to have to take a breath through this, even though it's going to feel a little uncomfortable for a hot minute, right? So let me tell you what we're looking for. We're trying to find this guy. So the first thing we're going to do is regular synthetic division. Are you ready? So we're going to take the 2. We're going to write our stuff out. I'm going to check my order. 4, 3, 2, 1, nothing. I'm good. And I'm going to write my numbers down. 2, -3, K, -5, and 10. Now I know, sorry dude, I have to get rid of your hand. I know at the very end, this whole thing is going to equal to 0. How do I know that? Because it tells me it's a factor. It's telling me that. If it told me it equaled 17 or had a remainder of 17, I would make it equal to 17 at the end, right? But it's telling me it's a factor, so I'm good. So now we're going to do just some basic math. It's not scary. Don't let it get in your head. Here we go. We're going to do it together. You guys with me? Let's start. Bring down the 2. There we go. 2 times 2 is 4. +1. 1 times 2 is 2. Now hold on a second here. I got a letter and a number, and I can't add them. They're different things. So how do I write it if I want to add K and 2? So close. That's timesing them. 2 plus K, right? Just 2 plus K. Or K plus 2. I like K plus 2 because K's in the front. It looks fancy. But the other one is fine. Are we cool with that? Numbers add with numbers. Letters add with letters. Now the next thing we're going to do is multiply. 2 times all of this stuff. I want you to talk to your neighbors, do a little bit of baby distribution, and put whatever you get right there. It's 2 times K and 2 times 2, right? It's not scary. I heard it back there, 2K plus 4. Did I hear that? Okay. Numbers add with numbers. K's add with K's. So it looks like I'm going to get 2K plus how many? -1, right? 5 and 4? -1. Do the next one yourselves because you get the hang of it now. Do a little bit of baby distribution and let's see what happens. Okay, here's what I get. 2 times K, 2K is 4K. 2 times -1 is -2. What I need you to do is put the 10 and the -2 together. And here's what we're going to get when we do that. 4K plus 8. Are we okay? Have I lost anybody? But you know and I know that equals what? 0, because at the end, we knew it was going to be 0. There you go. Go ahead and solve for K now.
Oh, that is okay.
I don't like this. Nope, but I'll answer for me. Okay.
How we feeling?
I will not, but I will come around and help. I'm going to stop taping. Okay.